Momentum is really like a measure of oomph. That's what my contemporaries, this is a video to the future. My contemporaries, I would have to explain, like, it's the common sense for us, because we're very primitive people back here. And you children of the future, I'm sure you find my descriptions trite and obvious, but give me a break. I'm explaining to my contemporaries. This tells you something about your history. They think of it as the graph paper sort of exists first, right? So if something's moving at a diagonal in their graph system, they would think of that as two velocities. Of course, it's really just, it's one velocity. You could always rotate the coordinate system so that it's going along the x-axis, and you'd have a vector where one value is always 0. And since velocity is relative, it's moving towards some other object. So you have this object, and let's just say it's moving right towards the other object. And that velocity that it has, we think of it as singular, but some people would think of it as having two velocities. Now, momentum being this oomph, how hard is the thing going to hit? It, quite commonsensically, is the mass of the thing times the velocity. So if the mass is twice as much, it's going to have twice as much oomph when it hits that thing it's going towards. The velocity is twice as much. If they're both twice as much, 4 times as much. Because it's like all the mass has velocity, so relative to that other thing. So it's mass times velocity, and velocity is a vector. It's a direction. Has a direction built in. You can either borrow the x-axis direction, or we can borrow a little bit from the x and y. And I guess that would mean for them that it had two momentums. But really, since you can rotate the coordinate system, it doesn't really have those directions. It has one direction that is in the amount of the magnitude. No matter how you rotate the coordinate system, that vector will have the same magnitude. So that's the thing that stays the same, right? Now, where they really lose the ball is that since velocity is relative, right, the momentum that it would have relative to another object, that would be different. And they would think, oh, well, that's two momentums as well. But really, that's still the momentum of one object, but relative to two different things. Right? And through all of the momentums, you can calculate what's going on in the system. And this seems very difficult. They don't seem to understand that. And so where they also really fail, many of my contemporaries, is in lacking this real understanding, taking the coordinate system as fundamental, talking about it as two directions when it's always really one direction, because it's one vector, regardless of what kind of coordinate system you use even. They then are confused about how this would affect a wave. If you impart extra oomph into a wave, what do? Well, you tighten its frequency. You make its vibration faster. That's more energetic, right? And they're very confused about this because they want to have a rule, some of them, just of small steps of contemporaries I'm talking about now. They want to think of that as violating the idea that there's one momentum. The fact that if a moving mirror hits a piece of light, it will impart some momentum, but instead of making that thing the photon shoot away faster, because it always goes at the speed of light, it would be more energetic and get more oomph through having a higher frequency, right? Because, as you know, and the scientists of my day know, higher, smaller wavelength light is higher energy light. They don't really get that, some of them, particular ones. So, yeah, just a message to the future so you could look back at my time and see what we were dealing with. Because when you see how crazy the politics is, you're going to think, what the fuck were these people thinking? So primitive. How did people so primitive have video technology at all? And this will help you.